February 20, 1943, north of the Kasserine Pass in Tunisia. The German battle reports of that morning would never fully convey the shock and disbelief experienced by panzer commanders. As the sun rose over the rugged landscape, a squad of American Sherman tanks began moving in a way that defied every principle of German armored doctrine. Through swirling dust and choking smoke, 5 Shermans advanced across broken terrain where visual signals were impossible. Yet somehow, without flags, flares, or messengers darting between vehicles, they converged on German positions with uncanny precision. To German observers, it looked almost supernatural. Each tank shifted as if it were part of a single body, seamlessly covering the blind spots of the others. Every American crew seemed to know exactly where their comrades were positioned, reacting with fluid synchronization that no amount of training alone could explain. In stark contrast, German Panzer Roman 4 struggled to maintain even basic coordination. Their Fuji 5 radios, though once considered state-of-the-art in the 1930s, were now showing their limitations. Static plagued the amplitude modulation system, drowning out voices and reducing orders to a garbled mess. The 10-watt German transmitters could barely reach a few hundred meters once the tanks were on the move, and electrical interference from their own engines only made matters worse. To make things even more restrictive, most German tanks carried only receivers. That meant they could hear commands, but had no ability to report back what they saw or to request support when the situation changed. In practice, this left units inflexible, bound to a rigid chain of command, and highly vulnerable when their lead tanks, the only ones equipped with full transmitters, were destroyed. The Americans, however, were operating with a technology the Germans didn't even realize existed: frequency modulation radios. Installed in every Sherman, these devices represented not just an incremental improvement, but a leap that would quietly transform the battlefield. With 25 watts of transmission power, more than double that of their German counterparts, and crystal controlled precision, these radios cut through engine noise and battlefield chaos with astonishing clarity. They allowed communication over miles of rough terrain, even while moving at full speed. What the Germans perceived as almost mystical coordination was in fact the invisible advantage of electromagnetic waves linking every American tank into a coherent, flexible network. This hidden revolution had begun long before that fateful morning in Tunisia. On July 22, 1941, the U.S. Army standardized the Signal Corps radio sets SCR 508, SCR 528, and SCR 538 for all medium tanks. At the time, while German forces were pressing deep into the Soviet Union, their armored thrusts still depended on fragile command vehicles and an outdated communication system. Meanwhile, in the United States, engineers at Galvan Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology. Daniel E. Noble, who envisioned the military applications of FM, and Henryk Magnowski, a brilliant RF engineer, overcame the enormous challenges of adapting sensitive electronics to survive the vibrations, temperature shifts, and dust of armored warfare. Their creation, though weighing 181 pounds, was rugged and dependable, turning every Sherman into a node in what historians now recognize as the first true battlefield network. At the heart of this breakthrough was the BC-6 104 transmitter, capable of generating 25 watts of power across the 20, 0 to 27, 9 MHz range. It provided 10 preset channels with crystal, controlled stability, ensuring that tanks could remain on frequency even under extreme battlefield conditions. Complementing it were dual BC-6 103 receivers, which allowed commanders to listen to multiple frequencies at once, for example, staying in touch with platoon movements while monitoring company-level orders. This dual-channel ability was unheard of in German armored forces and would prove decisive in combat. But perhaps the most significant element wasn't the hardware itself, but the shift from amplitude modulation to frequency modulation. AM systems, like those in German tanks, were vulnerable to every spark and electrical discharge, turning the natural chaos of the battlefield into unbearable static. By contrast, Edwin Armstrong's FM technology licensed to the U.S. military filtered out that interference, delivering clear, uninterrupted communication even during artillery bombardments. In practical terms, this meant that American tank crews could keep calm, coordinate, and adapt under fire, while their German counterparts were often reduced to hand signals, guesswork, or silence. When Operation Torch brought American armor to North Africa in November 1942, these advantages quickly became apparent. The 2nd Armored Division, landing near Safi and Fadola, carried with it not just tanks, but an invisible edge that no German intelligence report had anticipated. For the seasoned Afrika Korps, veterans of countless engagements, this unseen advantage would soon prove catastrophic. Their doctrine, which depended heavily on hierarchical command and limited communication channels, could not withstand the flexible, fast-moving coordination of American armor. And though the Germans would still win tactical victories, as at the Kasserine, past the seeds of a larger strategic shift were already sown. For the first time, it became clear that armored warfare was no longer decided by armor thickness or gun caliber alone, but by the invisible lines of communication that tied machines and men together into a single, adaptable organism. The Battle of Kasserine Pass, fought between February 14th and 24th, 1943, offered the first major demonstration of America's radio superiority in combat, though the battle itself was considered a tactical victory for the Germans, who inflicted heavy losses on inexperienced U.S. forces. The hidden advantage of the Sherman's radio network began to reveal itself in ways that unsettled German observers. Scattered elements of the U.S. 1st Armored Division, spread across nearly 50 miles of rugged terrain, somehow managed to maintain coordination. Tank crews who had never trained together, and in some cases had never even met before, were able to communicate, warn one another of threats, and call in artillery support with astonishing speed. To the Germans, this appeared to be the result of unusually disciplined training, but in reality, it was the crystal, clear voice of frequency modulation cutting through the fog of war. German signals intelligence quickly noticed something unusual. Intercepted American transmissions were not only shockingly clear, but also seemed to come from multiple tanks simultaneously. Reports from the 10th Panzer Division's intelligence section remarked that American units communicated at ranges where German radios would produce nothing but static. More disturbing was the discovery that nearly every American tank seemed capable of full two-way communication. This contradicted the Wehrmacht's assumptions that only command vehicles should carry transmitters. In practice, this meant that if an American platoon leader's tank was destroyed, any other Sherman could instantly assume command. German units, by contrast, were crippled when their command tanks, easily identifiable by multiple antennas, were knocked out, leaving the rest of the platoon unable to receive new orders. The limitations of German equipment were becoming painfully clear. The Fuji 5 transceivers, operating on amplitude modulation within the 27 to 3 MHz range, struggled to transmit more than 2 or 3 kilometers under ideal conditions. In combat, with engines running and terrain interfering, the range dropped to mere hundreds of meters. Electrical noise from spark plugs, motors, and moving tracks overwhelmed the system, making voice communication almost impossible in the heat of battle. Even worse, a standard German tank platoon of 5 vehicles typically included only 1 or 2 with full transceivers. The rest carried Fuji 2 receivers only, which meant they could hear but not respond. Orders flowed one way, down from the leader, but never upward. Tanks couldn't report ambushes, shifting terrain, or new threats. The rigid hierarchy made German units brittle, efficient only as long as the structure remained intact. The Americans, by contrast, had built resilience into their network. with every tank a fully equipped communication node. Information flowed in all directions. A platoon advancing through rough terrain could spread out, maneuver independently, and still maintain cohesion. A Sherman under fire could call for artillery or warn others of anti-tank teams waiting in ambush. The network gave American units adaptability that German doctrine considered impossible without visual signals or pre-battle rehearsals. The significance of this advantage became even clearer later in 1943, when American forces advanced into Italy. The mountainous terrain of the peninsula should have been a nightmare for radio communication. German tank crews relying on AM radios found their signals bouncing uselessly off ridges and valleys, often cutting off entire units from their commanders. Yet American FM sets, like the SCR-5, 108, thrived under these conditions. Frequency modulation handled multipath interference, the echoes and distortions of radio waves bouncing through mountains, far better than amplitude modulation ever could. Reports from the 1st Armored Division highlighted routine coordination across ridgelines and valleys where German radios failed completely. What should have been a natural advantage for the defenders became yet another arena where American technology quietly tipped the balance. For the Germans, this invisible disparity was difficult to comprehend. Their doctrine still emphasized visual signals and rigid land maneuvers, while the Americans were practicing what we now call flexible, networked warfare. When German officers tried to analyze why American units seemed so responsive, they often attributed it to training or discipline rather than equipment. Even captured intelligence reports in 1944 described American tank units as having good radio discipline, without realizing that the real difference was technological. This misinterpretation proved disastrous because it prevented the German High Command from recognizing their most critical weakness and therefore from correcting it. The irony was painful. Germany had, after all, pioneered the very concept of radios in tanks. General Heinz Guderian, the architect of Blitzkrieg, had insisted as early as the 1920s that every German tank should carry a radio. His writings stressed that armored warfare depended on communication and coordination. Yet by 1943, industrial shortages meant that fewer than half of Germany's tanks carried full transceivers. Production simply couldn't keep up. In 1943 alone, Germany manufactured nearly 700 medium tanks, but fewer than 2 Zero Fuji 5 sets. Command vehicles and assault guns were prioritized, leaving regular tank crews to fight effectively mute. Meanwhile, the Americans achieved the opposite. Every Sherman that rolled off Detroit's assembly lines carried a radio, no exceptions. This universal deployment, backed by mass production and robust engineering, turned what could have been just another tank into a vital part of a larger, flexible organism. German tankers might have had better guns and armor, but increasingly they found themselves fighting blind against an enemy that could see, hear, and respond as one. By June 6, 1944, when Allied forces stormed the beaches of Normandy, the Sherman tank was no longer just an armored vehicle. It had become the backbone of an entire communications network. As Shermans rolled off landing craft onto the beaches, their SCR-5, 108 radios were not only linking tank crews together, but also maintaining contact with naval fire support offshore. This level of coordination, tanks directing artillery and even naval guns while under fire, was something German commanders could scarcely imagine. Their own technology simply could not achieve such integration. Yet the hedgerow fighting in Normandy soon revealed a critical flaw in the American system. Tank radios could not talk directly to infantry radios. The Sherman's SCR-5, 108 operated in the 0 to 27, 9 MHz range, while the infantry's SCR-3, 100 walkie-talkies used 0 to 48, 0 MHz. The result was a communication gap that proved deadly. In the tangled bocage, German infantry equipped with Panzerfausts could slip within a few yards of American tanks, hidden by the thick hedgerows. U.S. infantrymen, often nearby, saw the danger but had no way to warn the tanks. More than once, Shermans were knocked out simply because they and the infantry were speaking on different wavelengths. The Americans, however, showed the same adaptability in communications that they had in technology. Within weeks of the Normandy landings, a practical field modification transformed tank infantry coordination. Crews began mounting E8 field telephones in weatherproof ammunition boxes welded to the outside of their tanks. These phones were wired directly into the tank's intercom system, allowing infantry to pick up the receiver and instantly speak with the crew inside. By late July, during Operation Cobra, this improvised but ingenious solution had become standard across U.S. armored divisions. The effect was revolutionary. Infantry could now guide tanks through the hedgerows, warn of hidden anti-tank weapons, and coordinate assaults in real time. A weakness had been turned into a decisive strength. Operation Cobra, launched from July 25th to 30th, 1944, showcased the full potential of American radio superiority. The 2nd Armored Division, under Major General Edward H. Brooks, coordinated more than 200 Sherman tanks in one of the most carefully orchestrated offensives of the war. Over the radios, units maneuvered like parts of a living machine, responding to threats as soon as they were identified. If one tank spotted an enemy ambush, others miles away could be warned within seconds. Artillery strikes, directed through tank radios, landed within minutes of being called in. German defenders from the elite Panzerlehr division, once considered among Germany's finest armored formations, found themselves facing an enemy that seemed almost omniscient. The contrast was brutal. German tanks, many of them operating without radios at all, had to rely on hand signals and prearranged plans. In Normandy's hedgerows, where visibility rarely extended more than 100 meters, this left them disjointed and vulnerable. Even the tanks that did have functioning radios struggled against interference and limited range. German coordination collapsed in the very terrain where they had once thrived. The irony was striking. Germany, the nation that had pioneered radio use in armored warfare, was now reduced to fighting with units that could scarcely communicate at all. The industrial statistics behind this disparity were staggering. By 1943, Germany was producing thousands of tanks, but only a fraction had transceivers. Radios were expensive, production was limited, and many were diverted to command vehicles or other priorities. Regular crews were left effectively mute, unable to adapt quickly once the chaos of battle disrupted their carefully planned maneuvers. The United States, by contrast, had harnessed its industrial power to ensure that every Sherman all 324 built during the war carried an advanced FM radio. Motorola's Chicago factory churned out more than 50 0 sets of the SCR-508 family, each containing thousands of individual components built to exacting standards. It was a miracle of production, reflecting the sheer scale of America's mobilization. The design itself offered advantages far beyond basic communication. Crystal, controlled frequency stability meant that channels could be preset before battle, and would remain aligned even under the vibration and shocks of combat. German radios, using variable capacitor tuning, constantly drifted off frequency and had to be readjusted, a near impossible task in the middle of a firefight. American commanders, thanks to the dual receiver setup, could monitor their platoon frequency while staying in touch with company command, ensuring instant flow of orders both up and down the chain. Crew members, connected through the BC-606 intercom system with throat microphones and noise-cancelling headsets, could speak clearly to one another even with engines roaring and shells bursting around them. German crews often lacked even basic intercoms, forcing them to shout or tap one another to be heard. The difference in combat efficiency was enormous. American tankers fought with confidence, knowing they could always call for support and share information. German crews, by contrast, often fought in isolation, cut off not just from higher command, but even from the tanks next to them. By the time Operation Cobra shattered the German front in Normandy, the lesson was undeniable. The side with superior communication held the true advantage. Armor and firepower mattered, but without the ability to coordinate, they were blunt instruments. The Sherman may have been outgunned by the German Panther and Tiger, but with radios binding every crew into a seamless network, it fought as part of something much greater than a single tank. By late 1944, the hidden power of American radios was shaping not just individual battles, but the entire tempo of the war. In September, the U.S. 4th Armored Division clashed with several German panzer brigades during the Battle of Arracourt in Lorraine. On paper, the Germans had every advantage. Their new Panther tanks outclassed the Sherman in armor and firepower, boasting long-range 75 mm guns capable of destroying Shermans before they could close the distance. Yet, when the smoke cleared after 3 weeks of intense fighting, the Americans had destroyed 281 German armored vehicles while losing only 41 Shermans, an astonishing 7-1 kill ratio. How was this possible? The answer lay not in armor thickness or gun caliber, but in communication. Every Sherman on the battlefield could instantly report enemy sightings. Tank destroyers received targeting information from tanks that couldn't even see their targets. Artillery observers riding in Sherman command tanks called down devastating fire missions within minutes. Instead of fighting as isolated machines, Shermans fought as a networked force, pooling their awareness and coordinating their strikes. The Panthers, despite their technical superiority, were forced to fight piecemeal, often blundering into ambushes or advancing without support, simply because their radios couldn't maintain coordination. The same story repeated itself across the Western Front. German intelligence, still misinterpreting American efficiency as mere discipline, failed to grasp that they were facing a technological revolution. A captured intelligence report from September 1944 praised American radio discipline and communication procedures, but never mentioned the fundamental superiority of frequency modulation. This blind spot prevented the Wehrmacht from adapting. They continued to target supposed command tanks, identified by multiple antennas, without realizing that every Sherman had the same ability to transmit and receive. Ambushes were planned on the assumption that American units would lose coordination when separated, but FM radios kept them connected across ridgelines, valleys, and miles of open countryside. By March 1945, as Allied forces closed in on Germany's heartland, the advantage of American communication reached its zenith. The capture of the Ludendorff Bridge at Remagen illustrated just how decisive radios had become. When the 9th Armored Division stumbled upon the bridge still intact, the discovery was reported up the chain of command within minutes. Orders rippled across 1st Army headquarters and beyond, and within hours, entire divisions were shifting to exploit the breakthrough. German forces, by contrast, relied on landline telephones, most of which had been destroyed by Allied aircraft. Their responses were fragmented, delayed, and often contradictory. Counterattacks arrived in small, uncoordinated groups and were quickly destroyed. Radios turned a chance opportunity into a strategic triumph. April brought another dramatic example during the encirclement of the Ruhr Pocket. American armored columns from the 1st and 9th Armies executed a massive double envelopment, trapping more than 300 German troops. This operation, involving multiple corps and divisions converging from different directions, was coordinated almost entirely through radio communication. Inside the pocket, German units collapsed into chaos. Fighter bombers, guided by radio, equipped forward air controllers, systematically destroyed German communication hubs. Field Marshal Walter Model, commanding the trapped forces, sent his final messages noting that units had lost contact with headquarters and with each other. Fighting continues, he reported grimly, but coordination impossible. The Wehrmacht, once feared for its lightning, fast blitzkrieg, was now paralyzed by its inability to communicate. The psychological impact of this disparity was profound. American tank crews fought with the reassurance that they were never truly alone. Even when isolated by terrain or enemy fire, they could still hear familiar voices crackling through their headsets, guidance, warnings, and encouragement flowing in from other units. German crews, in contrast, often fought in silence, cut off from support and unsure of what was happening around them. Otto Carius, one of Germany's most celebrated tank commanders, later wrote of the crushing isolation inside German tanks, where limited radios and lack of intercoms turned each crew into an island within the chaos of battle. At the strategic level, radios accelerated the pace of Allied advances. Patton's Third Army's legendary dash across France in the summer of 1944 was made possible by radio coordination that kept units synchronized across hundreds of miles. Orders, updates, and artillery missions moved faster than German forces could react. Speed, once the hallmark of blitzkrieg, had been wrested away by the Allies not through better tanks, but through better communication. By war's end, American technical intelligence confirmed what the battlefield had already shown. Reports concluded that German tank communications were at least 5 years behind American systems. Without frequency modulation, without universal radio deployment, and without electrical suppression to filter interference, German armored forces were fighting a war they could not win. The decisive factor was no longer steel or firepower, but the invisible currents of the electromagnetic spectrum. As the war drew to a close in 1945, the truth of American superiority in communications became undeniable. For all the fearsome reputation of German armor, the Tigers and Panthers with their powerful guns and thick armor, it was the Sherman, often derided as outgunned and underprotected, that proved decisive. Not because it was a better tank in isolation, but because every Sherman was part of something greater. A battlefield network that turned thousands of individual vehicles into a coordinated fighting machine. Radios, not armor plating, had tipped the balance. Production statistics told the story more clearly than any battlefield memoir. The United States produced more than 50 00 SCR-5, 108 family radios during the war, enough to equip every one of the 324 Sherman tanks manufactured. Germany, by contrast, built fewer than 6 Fuji 5 transceivers against nearly 12 medium and heavy tanks, meaning that at best only 20% of their vehicles carried full communication capability. The difference was stark. Where American tank units achieved near-total coordination, German formations often fought with only fragments of their strength connected. Even the Soviet Union, which fielded the war's most numerous tank, the T-34, entered battle with only a fraction of vehicles equipped with radios. By 1945, only about a quarter of Soviet tanks carried any kind of communication device. Against this backdrop, America's universal radio deployment stood out as a remarkable achievement, one that no other power came close to matching. The engineering behind these radios was as impressive as the scale of their production. Each SCR-5 108 contained nearly 150 individual components, from capacitors to crystal oscillators, all designed to withstand the punishing environment of armored warfare. The BC-6 104 transmitter and BC-6 103 receivers offered stability and range that German equipment simply could not match. Noise, cancelling headsets and throat microphones allowed crews to speak clearly even in the midst of roaring engines and exploding shells. Power supplies filtered interference so that sparks and vibrations did not disrupt communication. In short, American engineers had solved every practical problem that plagued German systems and had done so on an industrial scale. This technological edge reshaped American doctrine itself, U.S. Commanders could create flexible, ad hoc combat groups, confident that their units would stay connected. A tank platoon might be detached to support infantry, or artillery could be redirected mid-battle to respond to a new threat, all coordinated by radio. German commanders, bound by rigid structures dictated by their communication limits, were unable to match this adaptability. The contrast could not have been clearer. Americans built an adequate tank and gave it the ability to fight as part of a team, while the Germans built excellent tanks that too often fought as isolated individuals. The long-term lessons of this disparity echoed far beyond World War II. After Germany's defeat, both American and Soviet analysts studied captured equipment. Their conclusions were strikingly similar. German radios were outdated, fragile, and fundamentally flawed, while American systems represented the future of armored warfare. The Red Army, having relied heavily on U.S. Lend-Lease radios to fill gaps during the war, chose to model its post-war communication systems on American designs rather than German ones. When the Bundeswehr, West Germany's new military, was formed in the 1950s, it prioritized equipping every tank with comprehensive communication suites, a direct acknowledgement of the catastrophic lessons learned during the war. The impact of Sherman radios can even be traced into modern warfare. In the 1991 Gulf War, American and coalition forces faced Iraqi tanks that were in many cases technically superior in armor or gun power, but poorly equipped in communications. Once again, networked forces defeated platform-centric forces. In 2003, during the invasion of Iraq, U.S. doctrine emphasized network-centric warfare, a concept rooted in the very principles established by the Sherman's SCR 508 more than half a century earlier. The lesson remained the same. The ability to share information and coordinate as a unified whole outweighs the power of any single machine. Perhaps the most poignant testament to this truth came not from a technical report, but from a remark attributed to Field Marshal Wilhelm Keitel at Germany's surrender. "We knew how to build better tanks," he is said to have admitted, "but you knew how to make them work together." Whether or not the quote is apocryphal, it captures the essence of what the Germans missed and what the Americans mastered. The Sherman's gun may not have matched the German 88, and its armor may not have stood up in a duel against a tiger, but those shortcomings mattered less than the invisible lifeline humming inside every tank. In battle after battle, from the deserts of Tunisia to the mountains of Italy, from the hedgerows of Normandy to the final push into Germany, American tank crews proved that survival and victory depended not just on steel and firepower, but on connection. Radios turned isolation into coordination, chaos into unity, and a mediocre tank into the centerpiece of victory. In the end, the electromagnetic waves carried by the SCR 508 proved more decisive than the shells fired from any gun. They made the Sherman not just a machine of war, but a node in history's first true armored battlefield network. The Germans discovered this too late, realizing only at the end that the Americans had built not merely tanks, but an invisible web of communication that ensured they always fought as one. And in modern combat, that lesson still holds. Connection equals survival, and isolation equals defeat.